it's just gonna start shooting water here, right? Okay. So the height of this represents what? The height from this location up to the maximum that water, is spraying all over the place.
That represents the pressure.
The pressure head at that specific point. The pressure head at that specific point. So in other words, if I have any pipe, and that's why I'm trying you to understand the idea at least of the piezometer. So if I have a pipe, and you have water flowing in the pipe, and I drill a hole in the pipe, then what's gonna happen? It's gonna shoot water. Well, this height is the pressure at this point, is the pressure head in terms of height. So if I have a measuring tape and measure that height that is gonna shoot the water, that length represents the pressure head at that specific location in the pipe. Does it make sense? So again, the Bernoulli equation, you always do it from location 1 to location 2. An example now for you that I would like you to work. Let's do it for bonus points because I don't think you have too many bonus points for the final exam.
We only have one.
Okay, it's worth 10.
What?
What?
1 for 10 is no.
Yeah.
I would remember that. So you have now a hydroelectric power plant. So you have water enters the turbine nozzle. So you have a nozzle, that means this cross section, this is part of the pipe. You have a bigger cross section here, lower cross section here, okay? So you have here water. By the way, let me ask you this. Okay. Wait, let me see what it says. No, I don't want to do it like that. Let's see, here is your entrance and this is your exit. So water comes this way with a specific flow rate and it enters this nozzle, okay? Before we get into the numbers, can you tell me what does this nozzle do in general?
Well, it's going to increase the velocity.
Increase the velocity.
Reduces pressure.
Okay, correct. So now, the question says, water enters the turbine nozzles at 800 kilopascal. So if I have a pressure gauge here, it's gonna read 800 kPa. And it says with low velocity. So low velocity means, let's say, approximately equal to 0. I will help you a little bit with that. If the nozzle outlets are exposed to atmospheric pressure of 100 kilopascal, also now it's atmospheric here, okay? So here you have 100 kilopascal, okay? Determine the maximum velocity to which water can be accelerated by the nozzle. How much would be the velocity of the water exiting this one before striking the turbine blade? So find the velocity at the exit of the nozzle, given the pressures when it enters and when it exits. You have to use the Bernoulli equation along a streamline. Define the streamline. How many points you need to apply the Bernoulli equation? Let's start from there. 2 points. You need point 1 and point 2. It needs to be along the streamline. So which streamline you're going to use in this case? The center, right? So let's say you have a streamline and it's water, right? The density. Okay, I will give you the density of the water, 1,000 kilograms per cubic meter. I will help you on that. But this is your streamline.
We don't need distance.
You do not need distances in those problems. Distance between those 2 points, we didn't use the distance between the points.
Oh, yeah.
We just care about what's going on here in terms of pressure, elevation, and velocity, and what's happening here, pressure, elevation, velocity. The distance in between is not important right now. Later on, it will be important when we modify the formula. So let me see if you can find the speed. You need to apply the same principle, Bernoulli equation, from location 1 to location 2.
Can you change the position of 1 and 2? Or does it have to follow the direction of flow?
It needs to follow the direction, whenever we say along the streamline and along the direction of the flow. Now, here, I will agree with you, it doesn't make a big difference because it remains constant. So if it remains constant, that means if it is here 20, here it's gonna be 20. Yeah, you move along the line, but if it is 20 here, it will be 20 there, let's say.
No, move with the distance is the pressure because we have to do P2 minus P1, but P2 is less than P1. So
Oh, I see what you
so
mean,
I
yes,
get
yes.
negative under there.
Yes,
So
yes,
that
in
was-
that case it would have been negative, so yeah, you have to follow 1 and 2
Oh.
from the flow direction. Now, it will be more important when we do, later on when we include losses in the system, then when you move from location 1 to location 2, you have losses. Yes.
So, I think I got it, because
Uh-huh,
this is pressure.
very nice.
Very much.
Mhm.
And I didn't flip it because that would have been odd, even though this would have canceled out, this is the absolute, so this would have got it.
Wait, which problem is that? This is the first. Yes, perfect.
Awesome, good.
Very good. Oh, oh. Okay, yes, that's correct. What did we say about V1? If you're, so I'm guessing you're gonna start, here is your number 1 at this point, the flow goes this way, number 2 is here. What did we say about V1? It starts with a low velocity, okay?
Awesome, it's absolute.
So let me see. Z1, V1 per gamma, very nice. So if V1 is equal to what? Again, very nice. Okay. Gamma equals rho times G, so what I will do, I will substitute gamma rho times G, and then the rho is 1,000, and then the G is 9.81. It's not that difficult. You just need to be able, I want to see that you know how to apply the Bernoulli from location 1 to location 2. Bernoulli from 1 to 2.
What are those points?
I'll give you two bonus points.
When they start doing more. We got 3 for fine.
Well, yeah, but I was nice to you the first part, no? Oh, by the way, since I was nice to you, I forgot about that also. It's a good point to remind you that there are the ACI evaluations for the class. It's a good time that you remind me how many bonus points I gave you for the first exam. So make sure you go online and complete the survey. 1 means low, 5 means, okay? It happened before. One time I got everything 1. I don't know if they thought 1 is good.
Oh, is this mine?
Or they were really mad at me.
So-
No, they were saying you're number
One is
one.
not good.
No, you're number one.
Yeah, probably that's what they thought.
So that,
But-
right there, that
Yes. I said, okay, well, I mean, it's fine.
It's actually 800.
And not everybody's
Over
love. be happy. But yeah, be honest. It's okay. If you want 1-1, but it's good to do it.
This over
It gives us
time,
time.
it's literally the, what we did, first problem step you just
So would it be
apply it, it's literally it's this.
Mm-hmm.
Yeah. I did this.
P1, yes, that's correct. That's
We're doing a long way.
it. Just
back.
the allotted
So
number.
it's like,
He
it's the
just
same
said it
thing,
as-
because there's no height, there's no height difference, there's no, there's no
For
height
them,
difference, there's no
we use
secondary loss that covers.
You can use 98 then. Correct.
I just.
37.
Yes, you don't need to use it. Correct. Yeah, you don't need to use it.
37.
Yeah, the Z, I mean, it cancels, so you don't really need to use it.
Kilopascal is equals.
Kilopascal is 1,000 Pascal. So yes, if you wanna,
Equals 1,000 kilograms.
yes, so basically, so if you have P over gamma, because gamma is in Newton per cubic meter, this is to be Newton per square meter. So that means that needs to be in Pascal.
Yeah.
So your 800 kilopascal needs to be converted to 800 times 10 to the 3 Pascal times 1,000.
Put it, so put it in the calculator, just make sure.
You know what you got? Wait, so this what you got?
Oh, that's, oh,
And then your gravity has to be 9.81 times physical weight as well, right?
It's already meters per second square. Newtons, meters.
So I can correct my This one.
The 800, yes, because it's kilopascal, they need to be converted to Pascal because of the unit. The final answer,
This one was here?
yes.
They said it on computer.
don't
Very
have to
nice,
do it,
yes.
but you had
Very
to,
nice.
you had to open.
Which problem is this one?
What?
Which problem is this one?
This problem, oh, I didn't write the problem, I'm sorry. That problem,
12.15.
12.15.
12.15.
12.15.
How big is your number?
Hmm?
How big is
Dr.
your number?
Durham,
Big amount.
what you get?
37.
Yes, this one. Is this one or this one?
37.
Why you took the square root?
Yeah.
Oh, you need to?
Yeah.
Christian.
It's this. This is right here. So it's literally the problem before.
Oh.
Yeah.
See?
I'm gonna fuck up then.
7.
P over,
I'm gonna cross that because of that one.
now you're confused. P over gamma, this is not.
Might have
gamma,
typed it
this
in
is
wrong.
Z.
Huh?
This
And I
is,
might have put it in the
rho.
calculator wrong.
Can I see it?
Maybe.
Let me see what you
Times
did.
1.81.
Well, no, you got it.
Got it?
That's that first term that zeroed out because it was zero.
Did you
taken
convert
away.
this to 800,000?
Yes,
Yeah.
100%. Now, we have
In my
to,
calculator.
don't make mistake
Make-
with the unit conversion, guys.
make sure it's this.
Kilopascal needs to be
Make sure it's
converted to
this.
Pascal.
Not that, I'm just like.
Make sure
looking at the
this
difference
V square is
This.
converted to this.
And that.
Mhm.
This is what we.
Yeah.
To that.
Yeah, no, I gave
This is
you,
what-
yeah,
If you need help, put this in your
the
calculator.
thing is,
2 times 9.81 times.
Z, okay, in this equation, Z is here, right? P over gamma, so there is no,
So these guys go, so
indirectly there is no Z. But P over gamma is also P over rho Z.
Oh, okay, so,
Don't forget that, that's the confusion.
Okay.
okay, I see.
And then,
And then the
The
point
reason that I
85,
stick with the P over gamma is that if you
Huh?
keep the units correctly, the P over gamma will give you meters
over 90.
as a ratio, but P needs to be in Pascal and gamma needs to be in Newton per cubic meters, correct?
Hmm?
So let me, because this is important for me.
how I wrote, 98
So P over gamma, let's look at it. So let's say this is kilopascal and this is Newton per cubic meters. Let's say I gave you this one today. I gave you the pressure in kilopascal. Look what's gonna happen. Kilopascal is 10 to the power of 3 Pascal, Newton per cubic meters, equals. What is 1 Pascal equal to? Newton
Meters.
per
Newton per meter.
meter square. Okay, remember, it's because it's pressure, force over the area, force over area, over Newton per cubic meters. Newton cancels, and then cubic meters goes at the top, square meters goes at the bottom. What is cubic meters over square meters?
Meters.
So 1,000 meters. Okay?
So that, so our answer will be in terms of 1,000. We would have to multiply by 1,000 or divide by 1,000. Divide by 1,000.
Divided, right? Divided. No, I just want to make sure that the units work and you end up getting meters. Because if you leave it in kilopascal, that would have been kilonewton, they don't cancel directly. Okay? The final unit should be in meters. All right, time is up. Okay, all right. All right. Yeah, I mean,
I mean, literally, it's,
Alright.
this will be, I'm just gonna do, it's literally the same problem right here, except just follow these steps.
Yeah.
Oh,
You just
hang on,
replace
hang
this
on.
number with
Ah.
9800, so.
yeah, let's finish that.
Except don't have any height. So see,
Yeah, but we don't have any height, for other time.
any height, just replace this one.
How many
Pretty
blocks?
good.
Two.
Replace
That
with-
is actually very nice.
Mhm.
Okay. Adjust. You? Yeah, until I go back to my. Okay, so now we have another 5-6 minutes. I will finish a little bit more the theory. Limitations on the use of the Bernoulli equation. First of all, the flow needs to be steady. Steady flow means that everything is independent of time. They do not change with time. Velocity, flow rate, pressure, stay the same with time, not with space. So you can have velocity here different than velocity here, that's okay.